One of our next goals is to randomize the orientation of these particles. There is an orientation attribute that can be initialized, but I'd rather do this over time if possible, so I can animate the attribute and have random motion controlling the orientation of the particles to make it look as though wind is doing the job. For this I need additional ports in the ice trees, and I also need to actually simulate the ice tree. So I'll look for a simulate particles node, and it should be, if it's not in my favorites, it should be under the simulation folder in the tools menu. And if I pull in a simulate particles node, I'll plug it in at the bottom of my ice tree, and I'll add a few ports before the simulate particles node. So this first port after my emit and place node is going to take a set particle orientation compound. So let's look for some orientation. And under setters particles, we have set particle orientation. So if I plug the execute into port 2, I have sort of the means of just controlling the orientation of each of these particles here. And to control the orientation of the particles, I'm going to start by getting the closest location of each of these particles to this birch tree, to the geometry. And for that, we can look in closest as our filter and get closest location on geometry. It's found under surface interaction particles in the tasks particles toolbar. I'll pull this into my graph, and I'm looking for a piece of geometry. So what this measures is it measures the self dot point position, or the self dot location of each of the particles in the point cloud. And since our particles are actually generated from the same object that this ice tree lives on, this get closest location on geometry assumes that the object we're working on is a point cloud containing the particles we're working with. So I'm going to bring in the birch tree, so I can actually reuse the birch tree as my emitter object and output it into the geometry input of the get closest location on geometry, and then use the position and normal to drive some kind of a rotational vector and transfer that back into a particle orientation. So let's look for some nodes that we can use to take a couple of our axes and flip them around. So if I look up rotation under some of the rotation tools, we have axis and angle to rotation, and we have direction to rotation. If we look at axis and angle to rotation, it takes an axis that we define. So let's say I take the normal, the surface normal of the closest location of a point to a particular point on my polygon mesh. So we can actually retrieve the normal direction, maybe the local y-axis or the local x-axis. I'll drop my axis normal into the axis input of the axis and angle to rotation node and output that rotation into my set particle orientation. So if I start working these angles now, I should be able to control the rotation of my leaves. So right away I have a behavior that I didn't have before. I've already got a nice amount of randomness, and I could always randomize that as well on a per particle basis. If I wanted to try and randomize value by range, if my angle, let's see what my angle was here. So when I looked at my original angle, I was dealing with about 120 degrees, so I could pipe in a randomized value of about, I don't know, 90 to 180 degrees. And we wouldn't really want that animated because we'd start to get the chatter there. Although this looks kind of interesting for a fall day. So it's amazing what you can get just from a few simple connections. If I tried and increasing the number of particles there, say to 4,000, start to get a pretty nice behavior. But we're not quite done yet. We still have a ways to go.